we're going to look at some word problems where we're dealing with velocity and we have to find the max height. So this is kind of similar to what we were doing before, where we've got to plug it into the equation, and then we've got to find the line of symmetry, and then plug that line of symmetry in to find the y value of the vertex, which is going to be our max height for this. So we're going to write the function h to model the vertical motion for each situation. ht equals negative 16t squared plus initial velocity t plus initial height, and then find the max height. So when we look right here at number 16, so I'm just going to move it down so we can see it. This is number 16. Okay, and we're going to do ht equals, now it says my initial velocity is 32 feet. So we're still going to start with 16t squared. Okay. Got to make sure we're doing that. Squared minus my initial velocity, which is 32t, plus the initial height, which is 75. Okay, then we're going to use that whole negative b divided by 2a. And we know that b is 32, so we're going to say negative 32 divided by 2 times negative 16. And that is going to give me 1. Now we're going to plug that in to this initial equation here for t. And so we're going to get the negative 16. We're going to go 1 squared minus 32 times 1 plus 75. And this whole thing is going to equal just our max height, which is 91 feet. Max height. And this is the y value of the vertex as well. Okay, let's look at 17. We're going to plug the same thing in. We are always going to start with that negative 16t squared because that is the formula for this object going through the air. And my initial velocity is 200, so it's minus 200t. And my max height is 0. So I can just add 0 at the end or leave it just like this. My next step here is, again, to find that axis of symmetry. So use that formula, negative b over 2a. So we would say negative 200 divided by 2 times negative 16. That is going to give me my x value of my vertex, or my axis of symmetry, which is 6.25. Then I'm going to plug that into my equation where I go negative 16, 6.25 squared minus 200 times 6.25. And that's going to give me my max height, which is 625 feet. That's my max height. Remember again, that is also the y value of my vertex. Okay, so I'm going to go over here and I'm going to do number 18. Same thing, okay, for all of these. I'm going to put it into that equation where I use negative 16t squared minus 50 is my initial right there, so 50t, plus my initial height, which is 5. Then I'm going to plug it into the negative b over 2a, so that's negative 50 divided by 2 times negative 16, which is going to give me 1.562 Then I'm going to take that and plug it into my equation to find the y value, or my max height, or the y value of my vertex. So I plug in 1.5625. That is squared. Go here, here, squared, minus 50 times 1.5625 plus 5, giving me a max height of 44.0625 feet is my max height. Remember, again, that's the y value also on my for my vertex. 19, let's do this last one. Okay, set up our equation. We've got negative 16 t squared minus 48t plus 6. Then we're going to do that negative b over 2a. So we're going to go negative 48 divided by 2 times a, which is in this case is negative 16. And we are going to get 1.5. Then we plug it in. Negative 16 times 1.5 squared minus 48 times 1.5 plus 5. And that's going to equal our total, which is 42 feet. Okay, so that's it. We've done 4 different problems based on this, using that initial velocity and that initial height to find our max height for them. Remembering that our max height is also the y value of our vertex.